Shaama Sharada calls carbon dioxide, the worst offender of global warming, a very stable, very happy molecule. She aims to change that. Recently published in the Journal of Physical Chemistry, Sharada and a team of researchers at the USC Viterbi School of Engineering seek to break CO2 apart and convert the greenhouse gas into useful materials like fuels or consumer products ranging from pharmaceuticals to polymers. Typically, this process requires a tremendous amount of energy. However, in the first computational study of its kind, Sharada and her team enlisted a more sustainable ally, the Sun. Specifically, they demonstrated that ultraviolet UV light could be very effective in exciting an organic molecule, oligophenylene. Upon exposure to UV, oligophenylene becomes a negatively charged anion, readily transferring electrons to the nearest molecule, such as CO2, thereby making the CO2 reactive and able to be reduced and converted into things like plastics, drugs or even furniture. CO2 is notoriously hard to reduce, which is why it lives for decades in the atmosphere, Sharada said. Since the start of the industrial age, humans have increased atmospheric CO2 by 45%, through the burning of fossil fuels and other emissions. As a result, average global temperatures are now 2 degrees Celsius warmer than the pre-industrial era. Thanks to greenhouse gases like CO2, the heat from the Sun is remaining trapped in our atmosphere, warming our planet. The research team from the Mork Family Department of Chemical Engineering and Materials Science was led by third-year PhD student Carissa Cron, supervised by Sharada, a Weisgabelin assistant professor. The work was co-authored by Samantha J. Gomez from Francisco Bravo Medical Magnet High School, who has been part of the USC Young Researchers Program, allowing high school students from underrepresented areas to take part in STEM research. Many research teams are looking at methods to convert CO2 that has been captured from emissions into fuels or carbon-based feedstocks for consumer products ranging from pharmaceuticals to polymers. The process traditionally uses either heat or electricity along with a catalyst to speed up CO2 conversion into products. However, many of these methods are often energy-intensive, which is not ideal for a process aiming to reduce environmental impacts. Using sunlight instead to excite the catalyst molecule is attractive because it is energy efficient and sustainable. Most other ways to do this involve using metal-based chemicals, and those metals are rare earth metals, said Sharada. The team found that they can carry out systematic modifications to the oligophenylene catalyst, by adding groups of atoms that impart specific properties when bonded to molecules, that tend to push electrons towards the center of the catalyst, to speed up the reaction. Despite the challenges, Sharada is excited about the opportunities for her team. Gomez was a senior at the Bravo Medical Magnet School at the time she took part in the USC Young Researchers Program over the summer, working in Sharada's lab. She was directly mentored and trained in theory and simulations by Cron. Sharada said Gomez's contributions were so impressive that the team agreed she deserved an authorship on the paper. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.